Hi everyone, welcome to the first video of building LLM applications with BeyondLLM. BeyondLLM is a Python framework designed by us that can be compared to an all-in-one toolkit for building, experimenting, and evaluating retrieval augmented generation or RAG pipelines. Retrieval augmented generation is a technique used in LLM applications that help users to provide context or data to large language model or LLMs. This is mainly used to reduce the LLM hallucinations, which refer to the way in which LLMs provide incorrect answers confidently. We also use this technique sometimes over fine tuning because it is computationally less expensive and requires minimal resources that can also be done on cloud platforms. So now we have learned why we use RAG. Let's look into how we use RAG. Firstly, we load the data, which can be a PDF file, to a YouTube video URL. Then we pre-process the file or the text and store it in a separate database for faster retrieval. We do the pre-processing because we want to fit the entire chunk of text into the context length of the LLM. Then we initialize the LLM, and whenever the query is passed, similar text from the uploaded document are retrieved and passed to the LLM, which uses the query and the data and acts like a prompt to answer the original query. BeyondLLM streamlines the process of building the entire RAG application by providing features like fine-tuning, advanced retrievers, and a lot. This allows us to customize the retrieval quality with some parameters. In this particular video, we will talk about using advanced retrievers and evaluation metrics. So now we have understood the basics and we can start writing the code with BeyondLLM in this Colab notebook. I'll share the link of this Colab notebook in the description. So in the first text block, you will find the documentation and the GitHub repository. If you click on this link, you will go to beyondllm.aiplanet.com and find the entire documentation. Here you will find the embeddings, how to use the auto retriever, the evaluate retriever, and a lot more. Let's jump back into the code and let's connect to a runtime. So the runtime has been connected, and right now we will install all the required packages. We'll run this cell. After installing all the packages, the restart session message will pop up and you have to restart the session. Now we have restarted the session again. We can jump into the code. In this cell we have to provide our Hugging Face Hub token. I will put my one, and you can also create a new one by visiting the link here, and you have to log in into your Hugging Face Hub account and create a new API key. I have copied the Hugging Face Hub token and here I will paste it and hit enter. We also have to put our Hugging Face Hub token into the HF token environment variable indicated by this line. Now we have to import the libraries, which is source, retrieve, embeddings, LLMs, and generator. All of these components are required to build our RAG pipeline. So let's run this cell. So right now we have to initialize or define our data, which in this case will be the YouTube video. So the D type is YouTube here, and this video talks about Jupiter in AI Planet. So yeah, that's about it, and we have to run this cell. Now our data has been initialized. Let's see what our data looks like. So in the text you will find, hi everyone, you have struggled to learn some complex data science topics and etc. So this is the entire content of the video. You can also say this is the caption of the video, because this is the text form of the thing which is being spoken about in the video. Also, to do the text splitting, we have defined the chunk size and chunk overlap, which will divide the entire corpus into smaller chunks of text. Now the smaller chunks of text are to be converted to numerical embeddings. For that we define the embedding model, which in this case will be this one from Hugging Face Hub. So let's run this cell and we define our embedding model. So now we have defined our embedding model. Let's use it in the retriever. So this is the retriever. We call the retriever using retrieve.autoRetriever, and we pass the data, the embed model which we have just defined, and the type of the retriever. In this case it will be cross-read rank. Let's check what are the types of retriever that BeyondLLM has to offer. We click on this link and we go to this link, and these are all the types of retriever. You can find normal retriever, which is the default one, the flag embed rejunk retriever. We also have a hybrid retriever, but in this case we will be using the cross encoder re-ranker retriever. So what it does is, it compares the embedding of the query, because query will also be a text, so it converts the query into numerical embeddings and compares it with all the document embeddings so that the most relevant document comes at the top or comes first, and that's how it works. So let's define the retriever using the type cross rerank, and the top key will be 2, which means the two most relevant documents will be retrieved. Let's run this cell. Yeah, now we have defined our retriever. Now let's validate the retriever by asking a query. So the query will be, which tool is mentioned in the video. The ideal answer will be Jupyter. Let's see what it returns. So the text which is returned by the retriever is correct because it has Jupyter, which is related to the question that is being asked. So that means our retriever is working fine. Let's continue to the next part. So now since we have defined our retriever which retrieves all the relevant documents, we need an LLM to pass the query and the retrieved document as a prompt and generate an ideal answer to our query. So in this case we will be using the Mistral model, which has 7 billion parameters from Mistral AI from the Hugging Face hub. And let's initialize the LLM by running this cell. After defining the LLM, we also define the system prompt, because almost every open source model in Hugging Face requires one to generate the output in a correct format. So let's define the questions as well and the system prompt. Now after building the individual components of the RAG, we combine all of them with the retriever, which is the question, and also the system prompt along with the LLM. So we are doing that using the generator.generate function. We run this cell and then we define the pipeline. In this case, the question will be the question 1, which is what organization the video is mentioning about. So if we do the pipeline.call, it should return AI Planet. Let's see what it does. So the answer is AI Planet, which is correct. After building the pipeline and validating it, we can now evaluate the pipeline. By evaluating, I refer to evaluating the performance of the pipeline. If you go to this link, you will find all the types of evaluators that BeyondLLM has to offer. The first one is the context relevance, which measures the relevance of the chunks by auto retriever in relation to the user's query. The answer relevance evaluates the relevance of the LLM's response to the user query. It assesses the LLM's ability to generate useful and appropriate answer, reflecting its utility in practical scenarios. By the way, all the scores are from 0 to 10. So if it is near to 0, it's not doing a great job. However, if it's near to 10, then it's doing a great job. So after answer relevance, we can go to groundedness, which determines the extent to which the language model responses are grounded in the information, which is more related to the information to the query that is being asked. The ground truth also measures the alignment between the LLM's response and the predefined correct answer provided by the user. So if you provide an answer, the ground truth method checks whether the original answer is similar to the generated answer or not. Finally, we have the RAG triad, which combines the context relevancy, the answer relevancy, and the groundedness, all of three together to form a single metric. So in this case, we will be using the RAG triad method only. You can invoke this method by using pipeline.getRagTriadEvals. We have done the same, and let's run this cell. It will take some time to generate the evaluations. So the groundedness score is 5.0, the answer relevance is 10.0, and the context relevance is 10.0. So out of 40, it's getting 35, which is quite good in my opinion. Right now, let's ask the pipeline again regarding question 2. The question 2 is what tool is mentioned. Ideally, it should return Jupyter. Let's see what it does. Now we define the pipeline again, and then we call the pipeline. This gave us Jupyter, an AI tool for explaining complex data science topics in various formats. So it did quite a good job. Let's see how it does in evaluations. So the groundedness score is 7.0, the answer relevance is 10, and the context relevance is also 10, which means out of 40 it has scored 37, which is great. So as you can see, building this entire RAG pipeline took me just a few minutes. You can also use your custom data, which can be your resume in the form of a PDF or a CSV file or anything else which is supported by BeyondLLM. You can also experiment with the type of embedding models, the LLMs, and also the prompt if it gives a better answer also. You can also use different types of advanced retrievers. In this case, we use the cross-rank retriever, but you can use a different one as well. So if you like this video, please let us know by clicking on the like button and also subscribing to the channel. Stay tuned for more such videos.